Thank you for joining us and welcome to the Stantec Water webinar series. Hang on tight as we navigate you through the perfect storm and finding tactical solutions and advancing operational technology. We are pleased to present Pete Percivali, Kevin Johnson, and David Wilcoxon as they discuss how to get the most out of your assets, operational performance, resolve labor shortages, drive more effective procurement models, and navigate cybersecurity and environmental regulations. I am Heather Dean, your hostess. And during this meeting, you'll be in listen-only mode. We invite you to submit questions at any time during the presentation by selecting the Q&A dropdown at the top of your screen. Your questions will be addressed following the presentation. We will also be dropping announcements in the Q&A window, so make sure to open it now. And with that, Pete, I will kick it over to you to get us started.
Thanks, Heather. I'm Pete Percivalli. Today's agenda, we're first going to start off with defining operational technology, what it is, what it isn't. We're going to talk about some key challenges that all of our clients face. It's topics that we talk about every day in the operational technology business. Then we're going to take a look at how we help customers overcome some of these challenges, do a quick summary, and then get into Q&A. So let's talk about operational technology. What is it? Well, we have this IT ecosystem that every organization has. We have the IT ecosystem generally connects people inside the organization across their enterprise to processes and tools, Microsoft Word, billing systems, Excel. And IT is there to create productivity of that labor force. That's its fundamental duty, is to keep productivity high inside the labor force. OT is a little bit different. It takes a select few folks in the organization, but it's about connecting people with assets and machinery. Those assets and machinery produce the product that the organization is created. In the case of water, it's producing clean water or cleaning wastewater is the end product. So OT connects people with assets. So a little vocabulary. In the IT side of the business, we often talk about operating systems, the internet, the data servers, data centers, cloud and storage devices. We have a social media and web presence that IT is often managing. IT's priority is security. Its fundamental responsibility is to protect the organization and create security and produce those productivity tools. It's risk. When IT goes down, we have cyber threats, obviously, but it's really productivity loss. IT response times are in minutes and sometimes hours on planned outages. And again, its fundamental risk is loss of productivity. So its priority is to protect the finances and sensitive data and reputation of the utility or organization it serves. OT, a little different vocabulary. We talk about PLCs and distributed control systems, SCADA servers, OPC servers. We have control programming for pumps, valves, conveyors, digestion, aeration, all of these process-related devices out in the field. And its priority is availability. 5 nines, 6 nines availability, and security isn't second, but we would rather, in most cases, rather take measures to isolate than to lower the availability of the production system. Loss of production is a big deal, and as far as risk. And the other thing with operational technology is we're dealing with large rotating machinery, large switchgear in many cases. Loss of life can be part of a risk portfolio in OT also. Our timeframes are seconds and subseconds in the OT space. So the priority is system uptime, availability to prevent that loss of production and keep in regulatory compliance. Different sets of priorities across the organization. Today, whether you call it Industry 4.0, 5.0, or integrated OT, whatever name you sort of attach to it, there's this fusion space that exists between IT and OT. For the technocrats on the call today, this is Purdue level 3.5. But there are a lot of great applications that fit inside this fusion space between IT and OT. In other words, there's data exchange and network extension in between these two systems. For example, a lot of dialogue around digital twins today. These can range everything from an emergency response model to a training system that uses data from both sides. We've been talking about in this industry real-time asset management for years. That's where an application like that would fit, and even regulatory compliance models. And lots of applications exist in this fusion space, and we can list a whole bunch of them. But it's getting set up to deal with these things in this fusion space between IT and OT. So I'm going to move it to David here to walk you through some of the things we talk about every day with our clients.
Great, thank you, Pete. So what are some of the 5 key challenges that Pete just mentioned? Well, first would be OT system obsolescence starts day 1. Next, CapEx results in OpEx escalation. Next one, a lot of utilities obviously are dealing with this right now, is worsening labor shortages. Next is increasing cybersecurity threats. Next, proliferation of utility data silos. So let's look at the first challenge, what we have here. So OT system obsolescence starts day 1. So typically what we see on this is that OT obsolescence typically is the owner's burden. So what do we mean by that? So this could include system hardware upgrade costs. It could include licensing costs. It could include warranty, dealing with what warranty your system has, product cost exposure, interoperability issues that potentially are out there. And then also an important one is spare part inventory, having to maintain what that inventory is and not having to go to something like eBay to actually get some of your spare parts. And then the vendor part of this is they have to do with obviously the important part as well, as far as the delivery of the scope of work in the contract. Next slide. So let me give you an analogy. There are 2 ways to buy a car. You're probably familiar with the one on the right, but the one on the left, you're probably not. The one on the left actually is more analogous with a CIP project approach, in which you buy large pieces of overall project that you have that fit together, but is much more of a burden actually to the owner or client. If, however, we treat the OT system more like the purchasing of a car from a dealer, then we can negotiate things like cost, warranty, maintenance, and part replacement actually when we need it. Next slide. So what are some of the actual key portions of this as far as an effective OT agreement are concerned? Well, they could include the warranty, repair, and replacement, and actually have it in the contract to make sure that your system is kept up to date. It could also include 10 years of competitive, or more, actually, a competitive and predictable pricing. Can I have in there a clear understanding of what your data is and what the ownership means as far as deliverables and your intellectual property? You also look at potentially shifting that risk from the utility to the vendor where we feel it's actually better suited. And then the last one on here is commercial protections to make sure and ensure that the property and is executed actually in a good way following the actual specifications and drawings, things like that. So making sure that that actually gets done properly. So next. So here we have an example that we actually worked with the City of Los Angeles Bureau of Sanitation. As part of this, we were able to actually save right up front $120 million in OT system capital costs by the implementation of the agreement. We're also able to avoid some of the typical risk, which is from protection from either technology obsolescence, inclusion of unit pricing, which protects against price gouging in the future. And then we also included a system refresh, which was built into the agreement. We'd actually, after a period of time, this particular one was after 13 years, actually the whole system was refreshed. And so you're actually kept up to date. And that burden then, again, is taken off of the client. So next slide. So crucial element of this is that the traditional commercial approach burdens the owner with the risk and upkeep of the OT environment. Next slide. So next challenge we look at is CapEx spending typically escalates OpEx costs. So what does this mean? So the graph on the left shows a typical approach where your operational spending essentially grows with assets that are installed. But those installations of the operating assets could vary over time. And depending on your actual project itself or program, they could go up or go down. But typically, your assets don't have an actual impact on the overall growth here of your OpEx costs because you still have to maintain that as far as your operational costs are concerned. Well, what if we could make it more predictable? And what we're looking at here on the graph on the right is actually incorporating this as more of a programmatic approach for OpEx costs, where we're able to actually bring down that O&M spend and make it more predictable over time. Next slide. So how do we make that more predictable? Well, obviously we will always have the traditional I&C engineering approach with the development of P&IDs, the inclusion of electrical and I&C design, the typical integration part of things, and then we go into the construction side where at pre-commissioning, commissioning, client training and handover, and then system testing and deployment. But when we make this part of a more programmatic OT approach, we then look at more of the other aspects of things that make it more predictable, which include your business goals, the procurement solutions, doing an economic analysis to make sure things, again, are correct as far as when you want to do this and what costs are associated with it. You look at the life cycle costing of the equipment itself. And then again, on here, you look at the CIP program overall, and you make sure that those particular projects are integrated on a programmatic approach. So this actually makes it to a point where you actually have more optimization of your OT approach, you make it more predictable, and you actually are reliable then to make sure that you're in regulatory compliance with what you have. So what are the benefits of this approach that we see? Well, overall, we think that there is a savings in costs and risk where we're able to shift some of that risk for sure over to the vendors and have the better procurement model associated with that. We have innovation is accelerated, we believe, and this enables more rapid deployment of the OT tools. OT becomes the system to optimize and actual increase of staffing levels. So what do we mean by this part? This is important because what we're able to do here is we're able to have automation, more automation be included on this as far as that optimization aspect, which then tends to also then have an impact on the level of staffing that's needed as part of that. And then the other benefit here is in the delivery, design reviews, testing and commissioning procedures are all standardized and more predictable, which again lowers the costs and risks. An example of this that we see is City of San Diego that we've worked on. They added actually 5 times our operating assets. They originally started out before their program with an $84 million O&M cost. And then as they went through the capital program, again, they added 5 times the new assets that they originally had. but they only increased actually their O&M costs over a 12-year period after that to $87 million. So again, only added about $3 million to that. But in the meantime, as part of that program, they added 3 new treatment plants. They also added 11 major retrofits to the existing Port Loma treatment facility. And how were they able to do that? Well, they included on this high levels of automation and not just having remote control from the control room, which actually added an item here as far as staffing optimization. They were able to reduce staffing as far as the operators were concerned down to 1 operator over 2 out of the 3 shifts and on weekends. But what that did also was that shifted the aspects of the staffing over to a more integrated, predictable maintenance aspect of this. So it didn't necessarily reduce the overall staffing, but it moved it more into the optimization and actually in the integration part of this with maintenance involved as well. So next slide. Essentially, what the crucial element of this is that OT more strategically implemented will optimize OpEx costs. Next slide. So what we have here is the next challenge. Challenge 3 is that labor shortages and skill gaps will worsen over the next 5 to 7 years, as we all are living with at this point. So the labor shortages, what we have categorized here, are both quantity and skill related. The quantity issue is that typically in water occupations, what we see is that it tends to be an older occupation here where people are older as far as the median age is concerned in waters, but then all other occupations tend to be less. And then if you look at it in more detail, you tend to see on here is the workforce under 23 years of age in the water industry, again, is less, as 10.2% of the water occupation. And then the overall occupation is 12.5. So you tend to see that there are less people in the workforce that are 24 years and older. We also see a skills issue. We tend to have quite a few people that are, working system controls, potentially more also on the SCADA advances. But as you move to the right on this graph right here, what we see is there's a diminishing direct involvement as far as skills are concerned. So we have less people involved in online analytics, real-time control aspects, AI and machine learning, which is obviously a big aspect that is coming in right now as far as utilities are concerned. And certainly as we move further over as far as algorithmic decision-making, there is less people involved in that. So there's really a skills issue associated with how we bring people on. Next slide. So how can we create an OT career path which includes more modern tech environment and help to attract and retain the workforce? Well, the good part of this is that there are people out there right now that are part of the Gen Y and which are the millennials and the Gen Z generations. Gen Y, essentially, they're digital natives. They've grown up with iPads, iPhones, different things like that. So they are much more aware, typically, of what digital means to their lives. And obviously, then the Gen Z generation, they're, as we're calling them, technoholics. They have a lot of things that they rely on in their lives as far as technology is concerned. And they actually incorporate a lot of these things, whether it be social media and different aspects of technology. So these are the type of people that we think that we should actually be encouraging to join the water workforce. Next slide. But what happens, though, is that if you don't have some of the people involved in this and the labor shortage continues, the bad part of it is that you have then service levels could drop, more assets failures out there, stressed out workforce, which you're probably enduring right now, and it could lead to safety concerns, which obviously is a big issue. But the ugly part of this is if you continue to be in the same vein, then you potentially have more things like permit and compliance violations. You have failing infrastructure, massive overtime that could potentially be happening, and you're at risk to have more cybersecurity intrusions. We're working right now actually with the city of Jackson in Mississippi on a project with some other consultants where we've seen some of this issue where the staffing levels got so critical that they weren't able to attract people into their workforce. And they had several of these issues that were occurring, and they had to go out, and actually what we're helping them with right now, and some of this is that they had to go out of state to try and find people to bring in that would help stabilize these issues. Next slide. So an example of how we've worked with clients over the years as far as this staffing levels are concerned are, first one is recruiting strategies, working with tech schools and looking for non-traditional labor pools, whether that be minorities, women, and different things that we can take a look at as far as the non-traditional people that we want to bring into the water industry. Also, we can look at how can we actually enhance the OT discipline, whether it be through compensation, looking at what we offer new grads, things like that. Workforce retention, that's a big issue, to try and maintain the workforce, and then looking at what a OT job actual framework looks like. Next one we think is staff augmentation. This could be, with either filling the gaps and making sure that we provide mentorship opportunities, but augmenting the staff of utilities could be something that they work with different clients and make sure that the people that are we bringing in actually are able to fill in some of the gaps that they see. And then also a key part of this we see are vendor partnerships. They know their systems best, and so their cybersecurity department can really help in trying to leverage some of their expertise and making sure that that partnership is working for the utility. Next slide. So what are the crucial elements that we see on this? Well, the aging workforce is not being replenished, and we need to then ramp up the OT skills that need to adapt to that. We're all in a competitive battle, and not only utilities, but consultants are also in that same battle for the next generation of workers that are tending to go to more of the tech industry. And there really is no silver bullet to solve this problem, that there are actions that I've outlined that can be taken. Next slide. So another challenge that we're up against is cybersecurity threats are on the rise and are more dangerous. So what are some of these? Well, ransomware, which we'll talk about a little later here, malware, and inclusion from things like email, internal sabotage that could occur, phishing associated with things, with email, combining with that with cybersecurity physical attacks, whether it be hardware in servers, and then some things that typically we don't talk about is like things like cryptojacking. So who are some of the bad actors that we're seeing out there, and how can what are our motivations? Well, cyber criminals are looking for profit, and then activists and terrorist groups are ideological. Thrill seekers, which I'll talk about a little later here too, as far as there's just get kicks out of this, a satisfaction. And then there's insider threats, which we tend to not think about too much, but we have things like discontented employees. And then also I've seen that there are some potential issues where your own staff are not necessarily following through on your cybersecurity, where they write things like usernames and passwords on the whiteboards in particular buildings. And I've actually seen this recently where we did an assessment for clients. So you got to watch out for some things where people are not following your own rules. So an example of the ransomware attack was that I was actually working with the city of Atlanta at this time. They suffered a major ransomware attack. And what that did is it caused a widespread city-run program outages. And it really raised the fears amongst the city employees as far as, what things are out there and how they could be attacked. And it changed the whole posture of the city. But after a year, what we were able to see on this is that the person who was responsible for the implementation or the changes of the IT posture or the cybersecurity posture was, one of the measures of success is that it comes down to having an action plan ahead of time. So that's really sage advice to make sure that you, as a utility or consultant, have an action plan that is already in place, and you're not waiting around actually for something like this to occur. So what are some of the essential elements that we see as far as the cybersecurity assessment is concerned? And this, again, is following the NIST standards. Well, things like impact analysis or risk scoring using tools such as the CSET, which is the Cybersecurity Evaluation Tool. This is free from CISA, which is the Cybersecurity and Infrastructure Security Agency. And then after the assessment, you can then look at implementing an incident response or recovery plan. Then you will need to disseminate risk communication through security training and awareness to your staff. Again, this is a key part of this. You can put in a lot of the things that we're talking about here, making sure you have assessments, but you really have to make sure that those communications go out to your staff so they're following what you need to do to make sure that your posture is a part of everything you do. So 4 immediate actions that we feel that should be taken immediately are ensuring that you have a 24-hour spotlight placed on all of your IT and OT assets. Second, applying an AWWA and NIST guidelines or standards to address the gaps that you have as far as the assessment that you just went through. Third, again, emphasizing this, put your OT vendors at the forefront of protecting their products. So bringing them in and consulting with them as they know their product better than probably you do. And then lastly, making sure that it's a way of life and not something you do once where you go through an assessment, making sure that that then is a key part of things like your IT or OT management meeting agendas that you have on a regular basis. So a crucial element we see of this is security is highly specialized and threats change all the time. And so most public and private entities need help in this area. So the last challenge we looked at on here is the core utility OT systems are often siloed. So next slide. So why is that? Well, what we tend to see with a lot of clients and utilities is that their operations and their maintenance of assets tend to be in different silos here, where operations is concerned with the SCADA systems that are implementation and controls, and obviously their regulatory reporting, which is important. And then the maintenance of assets with the maintenance department, they or some other department within the utility then maintains the CMMS, their maintenance management and inventory management. But what we advocate is what Pete mentioned earlier, as far as bringing in this fusion part, is then if we bring the data together here, we're able to then manage that data with either diagnostics, looking from operations, and maintenance then is able to respond to that. Looking again at the actual operating status of equipment, stops and starts, that and has impact on the maintenance system, where we're able to reduce things like work orders and actually going out and doing some calibrations. And then asset runtimes. This enables the maintenance system to look at things differently and not have as many things where they're actually going out and not seeing something that where they need to maintain it at that time, and actually being able to put off some of the maintenance because the asset hasn't been running for a long period of time. So anyway, there is a better way. We can leverage a more modern approach, which effectively what we're advocating here is really building it with an organizational outcome in mind, which we feel is less expensive. It takes a shorter period of time to get some of the desired outcomes. It enables vendor diversity, which you're able to work with different vendors to bring in this more modern approach, which and then brings us to a platform for innovation. Compared to that, what we typically see is a more ad hoc approach, which is more of a point-to-point integration of these systems, which then individual departments build their own systems, as they saw on there, where there's either the SCADA system or CMMS, which tends to be more expensive, and that takes a longer period of time to get the desired outcomes that you want. It actually then becomes much more highly vendor dependent on those systems. And it also tends to limit innovation when we're not sharing that data. One other aspect that we see is that there's a problem that people have tended to see over the period of time was just the cost myth. And what we have seen and looked at on here is that a lot of cost has come down. So bringing in that information, whether it be sensors, looking at the processing speed of data, looking at then also the bandwidth as well, as far as bringing in external data, all of these costs have come down over the years. So the limitation that we see as far as the myth of cost on this is not what we see anymore as far as a limitation that should then bring in on the data. So this is an example that we're currently actually in the planning and stages with the Regional Municipality of Peel, which is just northwest of Toronto. Here, we're working with the clients to put together a real-time control project. And what you see on the screen here is that we're combining resources here and data sources, whether it be rain gauges, whether it be flow monitoring out in the field. Then we're utilizing the clouds for that data. And then we're able to then bring out things out to the SCADA system, where we're able to show a lot of that information that's being brought in. But then we're also able to then bring it through DMZs, things like that, as far as the information that's had AI or ML transitions and things like that. And actually being able to show that information on dashboards, which our management could see, whether for planning, whether it be engineering, for design and implementation, and then also actually looking at different resources associated with that. So what this shows here again is an implementation of that fusion where we're able to bring different data sources together and then show that, whether it be in a SCADA environment for operations or management environment associated with dashboards associated with that. So the conclusion here is the crucial element that we see out of this is designing systems around business outcomes eliminates essentially siloed data. We're able to bring that in, and then the data sets associated with that data, which we think at that point increases interoperability. So with that, I want to pass that over to Kevin.
Yeah, thanks, David. So like to talk a little bit about how we're helping our clients, how we're engaged with them to evaluate their OT readiness and developing a roadmap to address those challenges that David just talked about. The problem statement that we typically get when we're talking with clients, it usually begins with one of these types of conversations. There's a concern with the overall enterprise OT direction. It could be the platform itself, it could be the commercial agreements, vendor support, but there's some concern with the overall enterprise OT direction. The other conversation we have is around some type of facility or asset level concern. It could be a treatment related, or it could be an asset class like pump stations. But there's some concern about how the OT system is managing those specific assets. Or it could be a concern or one or more of the 5 areas that David talked about. But essentially what we are doing and helping clients is doing that OT system evaluation based on this type of concern. And I'm going to show you some examples of this here in a bit. Again, David went through the 5 challenge areas. And so what we're doing on the OT readiness evaluation is we're applying benchmarks and standards to evaluate the current state and identify priorities. So in system obsolescence, which is challenge 1, David talked about the OT agreement principles, and we're essentially using those principles to do that assessment. On cybersecurity, for example, we're using the NIST AWW standards, which essentially is the de facto standard for the wastewater industry. So we're using that standard. But in each of these particular areas, whether we're doing them all 5 or just doing an individual assessment in one of these areas, we're using these solutions, these benchmarks that David talked about earlier. So here's an example of a client where we applied all 5 challenges. I've taken the client name off here to protect the innocent. But essentially what we did is we went through and we evaluated all 5 of those challenge areas. We did a detailed scoring roll-up. We then take that number and applied it to a risk score, and then applied a risk score assessment to it. So for example, in challenge 4, cybersecurity readiness scored very low on this particular example, and we identify this as a crisis. You can see there's also other items that are very high or high. Again, we recognize that there are probably some immediate things that people need to do. So this helps us get those priorities out. We also recognize that there's no way, given all the other priorities that you all have in your organizations, that you could undertake all these things all at the same time. So in this particular engagement, they wanted to be able to move their scores over 2 years into a low, medium risk category. Obviously, the cybersecurity stuff, they're not going to wait 2 years. I've already been dealing with that already. So again, this is an example where we're applying all 5 of those challenges to an enterprise. Now let me give you an example where we just looked at one particular area, which is cybersecurity. So here's an example where we applied the AWWA NIST standards to their organization. And we looked these are the 13 categories that the NIST AWWA standard has. And I've sorted this. And again, what we essentially did here is we applied a maturity level score. And you can see I've sorted in such a way I brought so for visualization, you can see there were 5 areas we identified as crises areas. And these were things around the network security, physical security. This category 13 is probably an interesting one for people because it's kind of a semi-new thing. It's cyber-informed engineering. So what it's basically saying is in your engineering standards, in your engineering design, your construction management, have you embedded cybersecurity as part of that process? And so again, the goal here on all these assessments is, first of all, to do it fairly quickly, and number 2, to be able to get to those priorities and get to those real issues. So just kind of step you through this evaluation process, and the evaluation process itself is really focused on identifying the key issues, the risks, the costs, the benefits, and the priorities. So essentially what we do is we do a current situation analysis. And what we do find typically is that people are aware of some of the issues already. But again, we're bringing some of those standards and some of those principles that may be a new piece of information, but we're applying those benchmarks and those standards to this particular current situation. The next step is probably one of the most important. It's really looking at risk and what's the consequence and likelihood of something happening. So for example, we'll use the ransomware example. What was the likelihood of ransomware happening, and what's the consequence? So in that particular example, and then what we do is we do an economic analysis. And there's sort of 2 parts to that particular example, where there's a cost associated with getting yourself out of hock, so to speak, from a ransomware attack. And then there's the real costs and the benefit associated with trying to mitigate or eliminate that kind of risk. And so we go through an economic analysis for each of these, really a return on investment type analysis, which then helps us shake out the priorities. And so what we find in most of these typical assessments, again, whether it's the entire organization, OT, or looking at a particular area, is we can shake out pretty quickly what are the immediate things that need to happen, and then put those things onto a planning roadmap. This kind of concludes our presentation. I do want to leave you with 5 key conclusions to help you navigate through the storm. So David talked about challenge 1, which was this programmatic OT approach mitigates the risk of system obsolescence. He gave you the example of buying a brand new car, and essentially in the case of Los Angeles, that new car was a new car for 15 years. And so that's a key thing in terms of being able to mitigate that risk of obsolescence. And challenge 2, we talked about the programmatic OT and how it enables OpEx to be more optimal and predictable. He gave you the example of the city of San Diego. The talent war, which is what all of us are involved in business these days, is we are in a fight for talent and attracting the workforce. And David talked about how to attract a workforce and target some of the workforce and be able to create a program to retain that workforce in a digital enabled environment. Cybersecurity, we're going to live with cybersecurity threats in perpetuity. But for us in this industry, it's important to be able to embed that into our planning, our design, and our operations. And lastly, David talked about how you build your OT systems with this organizational outcomes in mind. And we like to think about it, instead of building things sort of vertical, we're really building horizontal across the organization. So with that, Heather, we are done and we will take questions.
Great. Thank you, Pete. Thanks, Kevin and David, for your practical guidance and providing solutions to leverage automation investments. So we did receive a few questions throughout the presentation, so we'll just get started on that as well. I do welcome the audience to type in any other questions they may have in the Q&A as we go through these. So first question is for you, David. Who should be involved in an OT assessment?
Yeah, that's a good question. Essentially, what we think associated with this is that a number of different groups should be part of this. It's both from an engineering standpoint, it should be then looked at as far as from a operations and maintenance aspect as well, because what we want to have is a collaborative effort here with a lot of different people that can then provide the input that the utility would want. Because again, it's not different utilities are experiencing different issues that they need. So putting together this programmatic approach essentially will take a lot of different individuals based on what the individual utility would want at the time. So we will tailor the people that we bring in for this assessment based on what the needs are. But we should be prepared to look at it from a lot of different angles and a lot of different people that would potentially be involved. So Pete, maybe you can add to that.
Yeah, the one conversation that's been consistent over the last 30 years, you know, in the 90s, you know, I'm old enough to be in the business in the early 90s. We were talking about data silos. Interesting enough, today we're talking about data silos. The concept of building the systems in the OT stack, you know, almost strictly by department. There's a broader set of stakeholders that we need to bring in. We need to bring in, you know, even from the cybersecurity side on the IT, to get some input on how that works. The capital programming team, one of the new NIST, you know, 13 criteria is to start thinking about cybersecurity as part of the capital programs. You got to bring in that broader stakeholder to get rid of those data silos. If you're trying to produce an outcome of whether it be sort of lowered O&M costs from the perspective of not necessarily labor, but you know, more predictive maintenance, lowering the O&M supply budgets. You know, that is an integration of both O and M. And also on the IT side, being able to interface into the network and CMMS solutions that are stacked up somewhere in the utility. So broadening the context, broadening the group helps us get rid of those sort of silos we've been talking about for decades. It's a good question.
Thanks, Pete.
Great, thanks everybody. Next question is for you, David, also. If we just air gap our control systems and IT systems, doesn't that protect us from any major cybersecurity threats?
Yeah, that's another great question. A lot of utilities tend to use the air gap principle to separate out their SCADA systems from other areas such as, you know, business or the internet, things like that. And it has, you know, traditionally been a solution that a lot of utilities think that are certainly safer than what typically if you're connecting all of those data systems together, which, you know, we were advocating for there. But air gap doesn't guarantee that you're actually going to have a good result. I mentioned as part of my, you know, going through the presentation here, I've seen things where the utility doesn't actually implement their cybersecurity to the letter. And I mentioned the example in regards to people writing things like usernames, passwords on internal whiteboards, things like that. So, and it also, you can also get people that are malicious in what they're doing. You never know what's going to happen. So you can have people that will bring, you know, things into their servers or network switches, thumb drives that can have malicious intent. And so if you even have air gapping system that you feel and you put a lot of emphasis on, it still doesn't guarantee the fact that you're not going to have some form of cybersecurity issue. You need to implement it, which is why I was emphasizing making sure that you get that information out to staff. You need to emphasize that you need to follow that to the, you know, rigorously, because unless you do, you're not guaranteed to have the resilience and protection that you need, even if you air gap. Pete, you know,
Yeah,
and
there's policy. Yeah, there's policy and execution, and you know, an operator X brings in his phishing pictures, sticks the thumb drive in the workstation in the control room to show, you know, friends. You know, there you're exposed. So a lot of it is all the great cybersecurity rules that you can set up, even if you are air gapped, can be quickly violated by something without any malicious intent, but just by accident could cause a problem. Also, you know, we've seen utilities where, yeah, we're air gapped from the internet, but we have 3 RDP connections that is residual from COVID from operating at home. Well, those are still open. Yeah, you may not be exposed to the internet one way, but you got to really check some of those things. When you say you're air gapped, in many cases we find, well, yeah, you are in most ways, but sometimes there's some, you know, some residual things that still are in the system that you need to address.
Great, thank you. Pete, what
Yes.
if my procurement rules don't allow for a 10 to 15-year agreement with vendors? What can we do?
Oh boy. Yeah, good question. Well, a lot of utilities have sort of uh, have policy at least around this, particularly when it's a quote city of organization, where there's sometimes a 5-year a contract could only exist for 5 years. Well, as we sort of built some business cases around this, and a great example of this is Los Angeles and San Diego to some extent. Um, we really worked with the city procurement department. We worked with city attorneys to really have a hard look at, you know, this is a vendor, and typically these systems have life cycles of 15 years. You know, before any major change outs, that 5-year prohibition may make sense for sort of the construction side of the business, but this is more of a programmatic way of looking at this OT investment. And we develop a business case around it. And the business case in every case that we've had this type of situation where, you know, we're looking at a 5-year you know, typical policy related to this is usually accepted, that we, you know, with the proper business case in front of the right folks, usually moves it forward in a positive way. And if you look at retrofitting a utility, particularly a multi-facility utility, you know, Los Angeles being a great example of this, 4 major treatment plants, 6,700 miles of pipeline. You know, we just kind of said we can't do this in a 5-year window. It would just take longer on the implementation side. Good solid business case usually wins that argument.
Great, thanks, Pete. So following up on that question, David, over to you. Do you think vendors will sign up for taking the responsibility for managing system obsolescence?
Yes, I do. And we've seen examples of that actually, and Pete pointed that out, that I think that, if you're work with a vendor, they are really wanting to make sure that they have a success story, obviously, with the utilities ongoing. And the last thing that they want to see necessarily is to have systems out there that are either neglected, if meaning that the cards or parts of their OT system are allowed to go obsolete at that period of time. They want to have a regular cycle here as far as the vendors do to make sure that there are updates provided to the utility, whether that be for software reasons or whether it be in the hardware. We've seen examples here where systems have gone obsolete where if you don't actually have the vendor involved, where clients have had to go to eBay. I mean, literally had to go to eBay to get some of the parts that they need.
Right.
And obviously, then the reputation and things like that of the system, people will then look down at that and say, why was this allowed to happen? Well, it really aids both the utility and the vendor if you have a working agreement that is ongoing, that there is no obsolescence as you move forward. And certainly, I think the vendors have specific programs in place where they know obviously when things are going to happen and when things potentially will become either they don't sell anymore, or if there's a potential obsolescence issue, you will know ahead of time. You know way ahead of time. So that partnership, I think, is a key part of making sure that your systems are up to date. And I think definitely vendors will participate in that because it's in their interest too. So.
Great, thanks, David. Okay, David, on the San Diego example, you showed how they managed 5 times more assets. Were there staffing reductions because of this?
I wouldn't say there were staffing reductions, and actually, as part of this, the labor costs over the period of time of implementation did go up slightly. But what actually ended up happening was that there was a shift again in emphasis from necessarily operations over to more of a maintenance allocation of staff. So rather than necessarily reducing staff, it really was just because the implementation of things like automation and the predictive maintenance solution that was put in place, the shift was really to enable staffing to occur in other areas of the utility. So overall, actually, staffing levels either remain the same or increase slightly, but they just were reduced in certain areas. In some areas, they were actually expanded upon. Pete, maybe you can expand upon that too.
Yeah, it really they were faced with a unique situation, with privatization coming in, during the late 90s, putting a lot of pressure on the mayor's office with this huge capital increase under the Clean Water Program, building all these new facilities. So they were challenged not with reducing staff, but operating this massive new amount of capital with the same staff level that they had. So basically, it was sort of reorganizing the job functions, using automation to automate the mundane. And I know that sounds kind of silly and sort of a large, broad platitude, but it allowed them to take the quantity of operators and through some extended training and even use of early use of digital twins to be able to bring that level of operations sort of multi-facility as opposed to single facility, and use one operator on second and third shifts to run the treatment works. So they're fully staffed during the day, 5 days a week. And on the weekends, there's nobody there, but there is one operator operating all the treatment works. Now, you can only get there if you have high levels of automation. So the program in the capital planning side was addressing this optimization from the technology perspective. It was also addressing it from the people and training skills perspective as we move through the program. And that's in also the maintenance side. The system was engineered for the on-off, start-stop, maintain levels, stuff that we do with automation. It also was optimized around maintenance. So when we engineered something, we engineered, I&C to also support this shift in paradigm to maintenance. So number of start stops, equipment run times, any diagnostic information on large assets were all collected. This way we can write rules. And San Diego got to a point where close to 90% of their maintenance tickets were all proactive. And that really was the thing that saved them a lot of money over operations for 12 years, is getting into that predictive maintenance mode.
Great, thanks. We've had some really interesting questions today. We're going to take one more question from the audience. Pete, over to you. With your experience, have any of your clients automated the regulatory reports and maintenance reports?
Yeah, we actually, not to bring up San Diego again, but they've automated almost all of their reporting to a point where it happens automatically. The information is obviously historized in the OT side of things, but that's sort of brought out into that data fusion side. All those data sets are exposed, and those data sets are then reported on through an application inside the DMZ in that 3.5 layer, if you're referencing Purdue. In that 3.5 layer, the fusion space, where they have daily reports, they have monthly reports, they have yearly reports. All of that is basically automatic. So as far as regulatory reporting, all of that stuff is in full auto. The thing that they really only need to worry about is they have to look at the data at the OT level and make sure a instrument isn't out of service, and they may have to put some corrective notes in the data set. But the reporting functions are all automatic for the entire utility.
Great. Thanks, Pete. So with that, we're going to wrap it up today. Thank you, Pete, Kevin, and David, and thank you all for your attendance and participation. If you have any other questions for our speakers, their contact info is in the Q&A window. You will receive an email shortly with a link to download your participation certificate. We will also be posting this presentation on stantec.com if you'd like to listen again or share with a colleague. Our next presentation will be Wednesday, May 15th, where our panel will be talking about micromonitoring and infiltration and flow to reduce investigation and rehabilitation costs. We hope you can join us again soon.